Hello everybody, good morning. So we have talked about the first type of methods to determine the value at risk. This is the first type of method. Historical simulation. So basically you just rank the data and then find out the alpha quanta or the percentage of tails you want to measure the risk. Isn't it? So now we're going to use another second methods. This is the second methods. So this is the so-called value at risk using the gauge method. So the gauge method, basically you need to estimate the data set. Therefore, you can find out the possible models for it. And from that, the forecast value will be used to estimate the value at risk. Okay. So basically, let's say if you want to estimate, let's say estimate t plus 1 or h plus 1, then you need to find out the alpha naught, estimated alpha naught plus, sorry, this alpha 1, this alpha, estimated alpha 1 with the residual t minus 1, t, sorry, this should be t at time t. So these are all the historical data you have, plus the estimated data 1, t squared estimated. Sorry, this is the raw data you have. Okay, so from here, once you have estimated this value, this one, and this one, then you can forecast, let's say the 1 day ahead forecast, or let's say 5% var 1 day ahead forecast. Okay, so you need to find out the alpha 1, alpha naught, alpha 1, beta 1. Let's say you're talking about a models gauge 1 and 1. Okay, gauge 1, 1. So, okay, so we go to the MATLAB. So let's say you just open the file we have, let's say under the bar. So let's say I've created a .m file for MATLAB, gauge11, a gauge method, sorry. So here we have some coding here, not much, just to show how we do the forecasting. Okay, so basically this is the title. Let's say we can just put a title, forecast. Let's say forecast using forecast gauge. Okay, we want the alpha naught, alpha 1, and beta 1. So first of all, we just do the loading. So this is basically this is actually to loading the data set. Okay? So the data set is called data equity IDX. So if we run this, let's say we just run this under the editor, we run it. Then you should be able to see what is inside the data set, data equity. Okay? Still running. So this will be the forecasted value. And then, okay, so under the data equity, let's see what is inside data equity. So the description of your data, you just go and look at description of US equity index year 1990 to 2001. So there are two sets of data. The New York composite index. The second one is the NASDAQ composite index. So the source is actually, you can get it from the NYSE and NASDAQ.com. So what is inside the data? So in the data table called data table, so we have two series, NYSE and NASDAQ. Okay, so you just need to call or to extract the data from this data table afterwards. Okay, great. So this is there are two series now, isn't it? The NASDAQ and NYSE. So we select the NASDAQ. Okay, So this one basically is selecting the select NAS Nasdaq, okay, for our analysis. So here there's a function called price to return. This means you are converting, this is actually converting price, the price index to continuous compounded return. So from price to return, we use the function called price to return. Okay, so the series we want to do the transformation is Nasdaq. Okay, so n basically is the how long is your data set. So you have 3028 price, therefore you can only generate 3027 returns. Okay, because each returns you need 2 price to obtain. So then we're going to model. The first model we're going to look at this is the Gash. So this is Gash 1 normal. Okay, so the assumption for the epsilon the epsilon here, so there are two possible values you can consider. Let's say you have RT here, RT running out of battery. RT, you have let's say data not plus data 1 RT minus 1. Let's say this is AR1 model and epsilon. So this epsilon basically can be assumed, you can assume that this will following normal distribution, okay, with mean sorry, the z value. Okay, so this will be the z value. We follow a normal distribution with mean. It's a 0 variance. Of course, this one you're talking about Gash model, so this will be a non-constant hetero effect. Okay, or the epsilon t also can follow a t distribution with degree of freedom. Let's say 5 degree of freedom. Okay, this is just an example. So we can have two different assumptions for this. So in this case, we start with normal. So this is Gash 1 normal. So for the after that we use a function. So the function is called ARIMA. Okay, so we can have AR1. So this is basically an AR1 model. So there are two equations. This is the first. This is the return equation. This is for volatility. So in this model we have two equations. The conditional return, conditional to what? Conditional to the previous historical data. So this is the conditional variance. So sorry, this should be square. But this one is a forecasted value one step ahead. So if you just cancel the t, then this will be t minus 1, t minus 1. Okay, this is a forecasted value. Alright. So now we just go back to have a look at, then we use the estimate function to find out our alpha naught, beta naught, and alpha naught, alpha 1, and beta 1. Okay. So then we use a function called infer to generate the returns and the estimated model. So this one is actually the forecast. Okay. So this is the forecast. So in forecast, we're going to have three series. Y is the returns. YMSE is the mean square error for returns. And then V is the volatility forecast. So call the function forecast. And then under the specification EST MDL, this is specification. The forecast steps are, let's say, 500 days ahead. So returns is the original value, is the original price value. E naught will be the expected value for returns, and then this is the conditional variance for your using the original returns, the raw data. So for Y value, which is the returns, you can have the upper bound and lower bound. This means you have an interval forecast. So this one is the interval forecast. Okay, interval forecast. So this upper bound, lower bound. Then we just call we're going to plot it in the same graph. So we use a subplot. 2 row, 1 column. This is the first graph. Okay. So the rest is you have n observation, n returns, isn't it? N returns. So the 500 step ahead are plus 500. So this is from. So this is a forecasted value. Forecasted value. Doing the same thing, we forecast for there are 2 series, isn't it? Returns and volatility. Returns and volatility. So both of them. So at the end, when you run it, you will get this is a 500 step ahead forecast. This is for returns. This is for the conditional variance. Okay, right? So how do you know? How do you get the? How do you obtain the value? So y is your forecast for return, isn't it? So here this is a 1 step ahead forecast. Return minus 0.019. Then this is second day, third, fourth, fifth. They actually converge to a fixed value after that. So for variance, we look at V. V you have look at V. So V, this is a conditional variance over 1 step ahead until 5 step ahead, 500 step ahead forecast. Okay. So you want to do the 1 step ahead forecast, then you need to look at the estimated value. So we have AR1, GASH11 under normality assumption. So this will be our model. Okay, this is our model. So we just substitute this value here. This is data naught, data 1. This is alpha naught, alpha 1 and beta 1. Okay, so here we can just write down the forecasted value under the normality assumption. Okay, so this one, let's say we have a normal assumption for AR1. Okay, so based on because every time you run it, okay, so this value, the estimated value will be not supposed to be exactly the same, okay, but it will close to this estimated value. Okay, because due to the simulated value z. Okay, so let's say we have a set of data consists of, so under, let's say this is the first case, case 1. Case 1 we have, we're using the AR1 GASH11 norm, isn't it? So this is our model. So we need to what? To calculate the VAR. So we want to calculate the value at risk of 1 day ahead, 1 day. Of course, this is for 1 day, 1 day horizon for a long position. So long position means we buy the asset and then we hope the asset will appreciate. Then when we sell it, we will get the profits of the price difference. Okay. So the position, let's say we invested 100k. Okay. 100k. So what is our the maximum loss? Okay. For after 1 day. Okay. So today, let's say today invested, what is the maximum loss for the for yesterday for tomorrow? Okay, with how many percent confidence interval? So let's say this is the model, and so this is the MATLAB output. So you have a, let's say RT. So you just refer back to the estimated result here. Okay, estimated result. So we use this as the AR1. This is the GASH11. Okay, so this is AR1. This is GASH11. You just put this inside this. RT basically have, let's say we just write down 726. So the value close to this plus the data one 0.13816 RT minus 1. Okay, so this is AR1. So the next equation is the gauge model T square. Okay, so this is the estimated function 2.236. I said this is the result you get. So this will be close to 0. Okay. So the long-term return, the values, the volatility is close to 0 plus 0.11864 epsilon t minus 1 square, and for the gauge term 87313 sigma t minus 1 square. So obviously you can see that the yesterday volatility have 87% impact on the current one, yesterday and today. And the residual square or the shock square have around 12%, okay, impacting the current volatility. So how do we get the forecasted value? So we go to the V and Y and V just now. So Y basically is, this is the value forecasted return 1 day ahead. This is forecasted value for variance, conditional variance 1 day. Okay. So based on these two, we just write down the result, the forecasted value. Forecast. So you have a 1 step ahead forecast, let's say 0. minus 0.0019. Okay, just now you have seen it. So this is square for 1 step ahead is 2.571 times 10 power minus 2. So based on this, we can find the quantile first. So 5% quantile. So means the tail, the left tail, right, 5%. Then you can find out the var afterwards. Okay, so this is the Q, 5% quantile Q. So this basically can rewrite as the formula R1 minus your Z. Let's say 5% is, let's say 5%. Then the volatility or the sigma of volatility. So this is the 5% quantile. Okay. So you just plug in the value minus 0.0019. So this is 1.64 because the Z value should be at the negative value. So the volatility, this is square, isn't it? So we just use the square root. Okay. So you simplify the whole equation. The 5% quantile will be minus 0.02827. So the negative value basically referring to what? The left tail, okay, the left tail. Because standard normal distribution, this is 0. So this is negative, this is positive. So we find the 5% quantile. So to get a 5% var, this is quite straightforward. So this will be equivalent to the 5% quantile, or you just multiply 100k by 0.02827. So this is a 5%. Sorry, this is 5% var, right? 5%. So in this case, you just get the value. Like how much is it? Minus 2827. Okay, so this will be the amount of money. So you can just interpret this as with the probability 95%. Okay, we have 95% confidence. Okay, the potential loss. So in statistics, we might say we are 95% confidence. But in the finance application, we can just say with probability of 95%, the potential loss for next day, the next day, which is 1 day ahead forecast is, so negative is basically loss. It's 2000 or around 3%, okay, around 3%. Okay, so if you want to have a higher confidence interval, confidence level, let's say 99%, then you can just find out the 1% var. Okay, 1% var. So the Z value will be changed from 1.64492 to 2.3, 2.33, okay, around 2.33. So this will equivalent to $100,000 times. So basically this equation here, the quanta here, just change this value to 2.33. So the volatility is the same thing, 2.571 times 10 power minus 4. Okay, so doing the same thing, this will be minus 3,513. So in this case, the loss will be higher because the higher confidence level you're using, right, which is 3,513. So this is 2,082. So we are 99% confidence. So with probability of 99%, the potential loss will be next day will be 353. Okay. So this is using the MATLAB estimate the forecast or forecasted the value 1 day ahead. If you want to do 2 day ahead or T or N days ahead also can. Okay. But this is the 1 day ahead forecast for the VAR. Okay, if you invested 100,000 in a, let's say, stock market, okay, with a capital of 100,000, so this will be the 1 day ahead 5% VAR and 1%. Okay, guys. So basically, this will be the coding for the MATLAB to generate the to do the forecasting. Okay, do the forecasting. Okay, guys. So in the next session, we are going to use not the normal assumption for residual or short. So we're going to use the student T. Okay, so we'll have a look at with different assumption for the distribution, the parametric distribution. So what is going to happen to the value at risk at 5% and 1%. Okay, guys. So till then, see you guys in the next session. Bye.